Now, when you look at the case of electrolysis, M is equal to quantity of electricity in coulomb over 965006, which is 1 Faraday, times X. Now, the previous formula I gave you, N was the same thing. The only difference is that there is no molar mass. So the molar mass appeared at the end here because I'm talking about mass. But if I'm talking about number of moles, I don't need the molar mass here if I have these two values given to me. Remember also what S is. This S is the charge on the ion of the element. It could be, for the case of copper, it could be 2. In the case of aluminium, 3, and so on. Silver, maybe 1. Now, if you look at this case, you are given the molar concentration, you are given volume, and perhaps molar mass. You can still find M. What's the difference between this and the previous one? Let's look at the comparison. The previous one was N is equal to CV. There was no molar mass. But when it involves M, you must introduce molar mass, and you still get the mass that is given. In this case, the same thing, there is no molar mass when it was N. This case, when it was N, no molar mass. When it was N, no molar mass. So just note that difference so that anytime you see any chemistry calculation and you're asked to find mass, please remember the molar mass. It must be here at the end. That's the only major difference between finding number of mole and finding of mass in most chemistry calculations. Let's look at this simple question. What is the mass of 0.56 mole of sodium? Now the RAM, which we call the relative atomic mass of sodium, is 23 grams. Very simple. You don't need to stress your head. Just dissolve it. Know the formula? Remember what I said? In case you forgot the previous one, you can remember the previous one said N is equals to small m over big M. If you cross multiply it by 1, so that means that small m is equal to small n times big M. Okay? Because mass. So, and then notice that you are looking for small m. Do you have N? Yes. N is equal to 0.56 mole. Then big M, which is the RAM of sodium, is 23 grams. So how do I find M now? My M now is equal to my N, which is 0.56 mole times 23 grams. And if you do the calculation carefully, the answer is going to give you 12.88 grams. Depending, you can see approximates and make it 12.9 grams. That is exactly the answer to this simple question. Remember the formula N. But I'm looking for M, and Mr. Molar mass is always at the back there. So I have N times M, and it gave me this answer. Now let's look at another interesting SSC question. They said, what is the mass of 6.02 times 10 to the power 24 atoms of magnesium? And they gave us the molar mass of magnesium, which is very, very important to solving any question that has to do with mass. And also gave us the Avogadro's constant, which is 6.02 times 10 to the power 23. Like I said, by the time you're through with this series, chemistry will become a very simple thing for you, mostly in calculations. So what do you do here? You know you're looking for mass. And definitely I've told you that the one given is usually on top. So you have 6.02 times 10 raised to the power 24. That's the particles given. Divided by, the constant is always the divisor in most cases. So you have 6.02 times 10 raised to the power 23. Remember that at the end of any calculation that has to do with mass given, you have Mr. Molar mass. All of them times what? 24 grams. Simple. 240 grams. That's how simple it is. Do you now see how simple chemistry questions are? Just simple understanding. Another interesting WAEC question. The mass of potassium hydroxide required to make 200 cm³ of 0.5 mole per dm³ solution is dash. Is dash. That's very simple. And they gave you the molar mass because you're looking for what? Mass. Now, before you solve this, it's important you list out what is given to you so you don't make mistake. First of all, I told you that whenever you see mole per dm³, it's telling you that this is the molar concentration and the symbol is C. Okay, so let's start. So we have C. C is 0.4 mole per dm³. We also have V. V is 300 cm³, and I told you that in any case like this, since you convert, so link with dm³ here, you convert to dm³2. That will give us 300 over 1000 dm³. When you finish calculating it, it will give you 0.300, just 0.30, is okay? dm³. Then, what else is given? You have the big M. The mighty M is here. So we have the big M, which is the molar mass, and it is 56.0 grams per mole. Okay. Now, remember what I gave you as the formula for finding mass when you have molar concentration and volume. I told you, in the case of number of moles, just say N is equal to CV. In the case of mass, similar thing, just M is equal to CV. Doing different now is that you now added the big M. So with this information, my small m is equal to C is what? 0.4 mole per dm³, times V is what? 0.30 dm³, and the big M we have there is 56.0 grams per mole. Okay. Now, with this, I think let me do it again, that one. With this, I will just go straight and get my answer in the calculator. Thank God for Mr. Calculator. I just say 0.4 times 0.3 times 56. Wow. And the answer is 6.72. 6.72 grams. Don't you see that chemistry calculation is very interesting? Want to look at this interesting SSC question? Calculate the mass of zinc sulfate produced when excess of zinc carbonate is added to 50 cm³ of 4.00 mole per dm³ of H2SO4. The equation of the reaction is zinc carbonate plus H2SO4 plus zinc sulfate plus carbon 4 oxide plus H2SO4. And they gave us the molar mass of zinc sulfate, which is 161 grams per mole. Someone will ask, what's the essence of this equation? Is to help us to solve in case there's a change. Because looking at zinc sulfate, if there's any change here, maybe 2 moles or 3 moles, then we are going to multiply it by the molar mass. Because that means it's not 1 mole. This is only for, this is a per mole, that means per mole. So, but in this case, this thing means 1 mole, so we don't have any problem. Very simple. So let's list out what we have as our data here. So we have C. Where do you get a C from? Mole per dm³. That is molar concentration. That is 4.00 mole per dm³. We also have volume. V. V is 50.0 cm3. Remember the culture, the tradition, converts to dm3. 50 divided by 1000, all in dm3, will give us 0.05 dm3. What do we have? The big M. That's the molar mass of the particular substance we're asked to calculate as we produce. And the big M is already given to you, 161 gram per mole. Remember that why they gave us this equation is in case here is 2 or 3. We multiply whatever we have here by that 2 or 3. So with this information, it's over. That tells you how simple chemistry is. As long as chemistry calculation is concerned, we are the champion. We don't have rival. Let's do this. So we are looking for what? Small m. Small m, we don't know what it is. Remember the formula I gave you? Small m is equal to CV times the big M. Small n will only be CV, but if it is small m, there must be big M. So without much ado, we have M is equal to what's C? 40.00 mole per dm3 times, what's V? 0.05 dm3. What's the big M? 161 gram per mole. Let me say something here. You say, sir, why are you always adding these units? Yes, this is chemistry. It's not just mathematics. This unit tells us what this value is. So sometimes for you to make a very good mark, it's good to put the units. It gives you a kind of, it makes you ahead of many people. And it shows that you are truly a chemist. You are truly a chemist. So let's see what our final answer will be. Within a second, my answer is here. And it's nothing else but 32.2 grams. That is the quantity of zinc sulfate that we produce when excess of zinc carbonate is added to 50 cm3 of 4.00 mole per dm3 of H2SO4. Subscribe and you'll be getting our notifications and other calculations that will be coming up as we proceed. Remember, this is just part 2. Look out for part 3, part 4, part 5 of these videos, still in chemistry calculations.